Hello and welcome. We're going to have a look at the smoke testing of our Raspberry Pi development environment for our series on Introduction to C++. A smoke test is a quick and dirty test to make sure that something is reasonably correct. The reason we do this is because it's annoying when you spend an awful lot of time developing some software and to run into some issues only to realize later that the issues that you run into were to do with your setup of your development environment. What we'd like to do is just make sure that there are no issues up front and let us introduce our own bugs into our own software. This video, like a lot of other things on this Introduction to C++, are Creative Commons licensed under the attribution license. This means that you can share this video for almost whatever purpose you like once you give me some reasonable attribution, please. I am Aidan Delaney. I work at the University of Brighton. There's some contact information for me there. My Twitter handle, my research group that I work within, and my GitHub account. The source code for the project that we're going to build today lives on my GitHub account. I also make a number of assumptions about you. These may or may not be true, but I have to state them up front at least anyway. The first thing is that you have a Raspberry Pi device. Well, actually, it's not necessary that you have a physical Raspberry Pi device. We will and can emulate a Raspberry Pi software on a normal desktop machine. I also assume that you have some familiarity with the Linux command line. This means that you can change directory, list the files in directory, and ideally, if you could be able to use tools such as grep to search through things. I'm also going to assume that you have some familiarity with the Linux, the App Store model, as I like to call it these days, that you can use the repositories of applications that exist on Debian on the Raspberry Pi and install applications. For example, apt-get install is a command that will install whatever application you give it as a parameter. In this case, it's gedit. So, without further ado, let's move on to smoke testing our Raspberry Pi development environment. This is what your Raspberry Pi might look like when you boot it up and launch a terminal. Now, I should say that I'm using an emulated version of the Raspberry Pi software. This is so that I can generate nice HD video streams and record them to disk. Hopefully you have a physical device, and that would mean that your physical device will respond an awful lot more quickly than the way that the commands appear on my screen. So, for our smoke test, I want to check to see if we have two tools that are necessary, and then two libraries that are also necessary. The first tool I want to check for is the presence of our GNU C++ compiler. To this, I will type G++, which is the command name, and I'll ask it for its version number. Great. We can see that there is a G++ command, and the version here is 4.6.3. Again, I'm going to do this with Git, which is a tool that we will use. I'll ask it for its version. And you can see that Git version 1.7.10 is installed. Suppose neither of these commands were installed. I'm going to make up a command name here. Let's call it gear. This isn't a command, so when I hit return and ask the shell to find it, it tells me that there is no command, the command not found. So if your G++ returned command not found or Git returned command not found, you should go away and install those commands. The second thing that we're looking for are two libraries, the SDL library and the SIG C++ library. To look for these, I'm going to use dpkg, the Debian package system, dpkg. I'm going to get it to list everything that it knows about. These are generally installed applications. And then I'm going to search grep for things that match libsdl. Great, so what I can see is installed is the libsdl 1.2-dev package. this is the development the headers for the libstdl library, and similarly the development library, the headers for the libstdl library image subcomponent are also installed on my Raspberry Pi. The image subcomponent is nice because it allows us to use images such as PNG format in our game. Then I also wanted to use the same trick to search for SIG C++. And on my system you can see that there is libsig C++ dev installed, but you can also see that it's of version 1.0.4, which is a very old version that we can't use in this project. Instead, you can also see that there's a package called libsig C++ -2.0-dev, and this is version 2.2.10, which is perfectly usable by us. So in this case I've got both versions of the library installed. They won't conflict with each other. It's perfectly fine. Finally, I like the gedit editor for doing source code edits, and I'm going to make sure that it's installed on my system. Now that I've ensured that our C++ compiler is there, our Git tool is there, our SDL is there, SDL image is there, SIG C++ is there, and my favorite text editor, gedit, is there. The smoke test is complete. Our environment has everything that we need to go on and now. In order to build our software, we first must get it, and this is where the git command comes in. I'm going to ask Git to clone the public version of this source code, which is on https github.com/my username Aidan Delaney / the project name Starship Fontana.git. Git will now go away and clone all the change history of that project into a local folder, which we'll see there, called Starship Fontana. I'm going to go into that folder, do a directory listing, and you can see that in there's an assets directory, there's a license file, there's a make file, there's a readme markdown file, and then there are two folders, one for source and one for some tests for this code base. If you have a look inside assets, you can see that there are 3 PNG files, almost self-explanatory. Rather than burrowing further into this, what I'm just going to do is compile this source code. G++, our compiler, please compile everything in the source folder that ends in .cpp, and please use the C++11 standard. Now, we've got to tell the C++ compiler on Debian on Raspberry Pi how to use the C++11 standard, but slightly differently than you would a more modern compiler. This is because this compiler dates from just before the C++11 standard was released, when the C++11 standard was known as the C++0x standard. We also need to tell it that I want to use /user/include SIG C++2, and I need to find the lib versions of these includes user lib ARM Linux GNU ABI hard float SIG C++ 2.0 include. Now, I have stated before that some of these commands look like magic, and this one certainly does. I'm asking you to accept it for the moment, and later on in the process we're going to go and explain what all the parts of this means. But it is interesting to note that if I type this command on my nice Core i5 laptop, I would expect it to return almost instantly. So you can see how hardware constrained something like the Raspberry Pi is. It is almost like developing on a mobile phone or almost a late 90s CPU. The Raspberry Pi itself has some excellent graphics hardware which you wouldn't find in a late 90s desktop machine, but its CPU is a little bit slower than what you might expect in either your desktop or your laptop. So to compile a simple program probably takes the best part of 2 minutes, whereas it would be done instantaneously on a modern desktop machine. Now that that's all compiled, I'm going to go ahead and link the compiled sources into an output executable. I want to link all the .o files. I want to link against SDL image, and the 6C 2.0 version of that library, please. It will go ahead and link, and if I do a directory listing, what we can now see is that we have an executable file called Starship Fontana. If you were a Windows user, you might expect this executable file to end in a .exe. This is just unnecessary on most Unixes, Linux included. So what we've done so far is smoke tested our build environment and then actually built the software. Now that we've compiled our software, I'm going to execute the Starship Fontana binary, and what we'll see on screen hopefully is a plane down on the bottom which we can move left or right, and a series of attacking planes which we can annihilate by firing balls of fire at them, and they disappear as they get hit.